Hello dear students, today we have to discuss this topic, that is compound interest. So first of all we have to see what do you mean by compound interest. Compound interest is the interest calculated on the principal and interest accumulated over the previous period. So it's also an interest, like we calculated the simple interest, but there is a difference between simple and compound interest. It is different from simple interest, where interest rate is not added to the principal while calculating the interest during the next period. So in simple interest, what we did, we just take a same principal for all types of the periods. But here in compound interest, we had to take the principal different from the that of simple interest. You will understand this statement when we solve the questions, right? So, for example, if you have two periods, right? For the first period, it's 6 years, and for the second period, it's 2 years. So, after calculating the final amount here, for example, if it is the final amount is 3,000, and the principal here is $1,000, right? So, what we had to do for the second period, for this period, if we had to calculate this simple interest, we had to take the principal as the same 1,000. But if we had to calculate the compound interest for the second period, we have to take this amount as the principal, right? So you will understand this when we solve the questions. Then what it says, where we use compound interest. We use compound interest if we had to calculate increase or decrease in population. So these are the applications of compound interest. We can calculate the increase or decrease in population by using compound interest formula, and the growth of bacteria, rise or depreciation in the value of an item. We can calculate all of these things by using compound interest formula, right? So how will you find the compound interest? You will find the amount. Amount means the future value, right? Here you can see in the formula, amount is represented by A, is the future value, and principal is the initial value. So here you can see the formula A equals to P times 1 plus R over N to the power of NT. This is in the power of this bracket in the exponent, right? So if I wanted to write it here, I can write it like this. A equals to P times 1 plus R over N, and then to the power of NT. You have to remember this formula. This is the basic of compound interest. This is identity or formula to calculate the basic compound interest. Here you can find the future value, the amount A, right? And the principal will be given to you. So after calculating the amount, you will subtract principal from it. You will get the compound interest. Here A represents the amount, P represents the principal, R is interest rate. So this interest rate is always in decimal, right? And you have to take it in decimal. For example, if the interest rate is given to you as 50%, you have to take 0.5, because 50% means 50 over 100, right? And 50 over 100 is 0.5. So here you always have to take the interest rate in decimal. And what is N? N is the number of times interest is compounded per year. Means in a year, in 1 year, how many times the period is repeated. For example, if we look at annually, if when we say annually, it means it's repeating 1 times in a year. And if we say that it's semi-annual, semi-annual means after 6 months, so it will be repeated twice in a year. So in that case, if the compound is semi-annual, you have to take N as 2. Similarly, if it is quarterly, then you have to take it 4 times, right? If it is monthly, you have to take 12 times. We will discuss that in the next slide also. Here N is again the number of times the interest is compounded per year, and T is the time in years. Means what's the period, for how many years the interest will be imposed, right? So here you can see what the different, when the time period is different, the formula will be changed accordingly. Again, what was the formula? The formula to find the amount is A, and it's P times 1 plus R over N to the power of NT, right? So that's the formula. So annual compounding means it is repeated in just 1 times in a year. So N will be equals to 1. So if N equals to 1, this will become 1, this N is 1, and this N is 1. So the formula will be simply A equals to P times 1 plus R to the power of T, because these two N's becomes 1. Quarterly means after every 3 months. So it will be repeated 4 times in a year. So it will become R over 4, and it means quarterly means simply N equals to 4 in the formula. Monthly compounding means after every month. So it will be 12 times in a year, right? Because we know there are 12 months in a year. Similarly, daily compounding means after every day. So how many days are there in a year? We know there are 365 days in a year. So N will be 365. Similarly, if it is weekly compounding, right? If it is weekly compounding, then I think there are 52 weeks in a year. So N will be 52. So these are different identities according to the period. There is another type of compounding, continuous compounding. We will discuss that in the next slides. So here we have given a problem. right? You have to memorize this formula, how to find the amount. That is important thing. So if we look at this formula, what it says, a teacher wants to invest 30,000 into an account that compound annually. So first of all, you have to see what is this amount, 30,000. You have to write the data here. 30,000 is actually the principal amount, right? The principal amount, and compound it annually. It means it will be repeated just one times in a year. So n will be just 1, and the rate, interest rate, is 1.8%. You will represent R as 1.8%. If you convert it into a decimal, it will be 0.018. Right? This is R. Then how much money will be in the account after 6 years? 6 years means time is given to you, that is 6 years. So you have to take this data and find the amount. How much money will be in the account? So you have to find the future value, the amount A. So you know the formula P times 1 plus R over N to the power of N T. So you have to find A. The principal is given to you, that is $30,000, right? 1 plus R is 0.018. Our N is just 1, so you write 1 here, and 1, N is again 1, and T is 6, right? So if you solve all of this, this will become, if you add 1 plus 0.018, it will become 1.018, and here in the exponent 1 times 6 is 6. You have to times it by 30,000. First you have to calculate the exponent, like 1.018 to the power of 6 is what? You have to use a calculator here, then you have to times 30,000 by it. So I will use my calculator, and although you can use the desktop calculator, but I will use my own calculator here. It will save over time. So it will be $33,389.35, right? So that's the future amount. So after 6 years, there will be this amount in the account. Then you can read the next question here. Calculate the interest rate. So here, when we were discussing the formula, here you can see the next one. Calculate principal based upon future value. So you can rearrange the formula to find the principal, to find the interest rate, and to find the time, right? So here what they ask us, calculate the interest rate. Here we have to find the interest rate R. We have to find R. They started with 5,000 and now has 13,000. So what was the initial amount in the account? That was the principal. The principal was 5,000. And what's the current value? The current amount is 13,000, right? $13,000, and has been compounded annually. It's again compounded annually. It means n will be equals to 1, and time is 12 years, right? So you can first, you have to use the formula again. We know A equals to P times 1 plus R over N to the power of N T. So what's the future amount? The amount is 13,000. That's the current amount in the account. What was the principal? The principal was 5,000. And then 1 plus R. R is the interest rate. We have to calculate it. We don't know it. N is 1. You don't need to write 1 there. And time is 12, right? So then you have to divide both of these by 5,000. You know these simple calculations. These are very simple, right? So 13,000 divided by 5,000 is what? You have to use a calculator here. So it becomes 2.6 when I use my calculator. 2.6 equals to 1 plus R, then to the power of 12, right? So you can solve it here. You have to calculate R. There are many ways to calculate R. In this problem, I will tell you the simplest way. That is, when the exponent is 12, if you have to make it 1, you can take the exponent 1 over 12 here, and can take the exponent 1 over 12 here, right? So you can use a calculator to find the exponent, like 2.6 to the power of 1 over 12. So when I use my calculator, it gives me 1.08288 equals, here this 12 and 12 cancel out. It will become just 1 plus R. So subtract 1 on this side. These simple calculations, right? So you will get R equals to 0.08288. And if you have, because this is the interest rate in decimal, right? If you had to convert it into percentage, you have to times it by 100. So R will be equals to 8.288%. That will be the interest rate in percent, right? So here this for this step, you can also use the natural logarithm, and we will try to discuss that in any of the next problem. Then let's see what's the next problem. Question number 6. 1,200 is placed in an account at 4% compounded daily for 2 years. So you have to understand the data. Here, what is 12,000? 1,200 is actually the principal amount, right? And what is 4%? 4% is the rate. You have to take it a 4% because in the formula we have to use the rate in decimal, so it will be 0.04 in decimal. Compounded daily. So you always have to note that what type of compound is there. It's compounded daily. It means n will be equals to, it will be repeated 365 times in a year. So n will be 365 and the time is 2 years, right? What you have to find, what is the balance in the second. It is then withdrawn and placed in another bank at the rate of 5% compounded daily for 4. Here you have given 2 periods. For the first period the rate is 0.04, right? And the time is 2 years. For the second period the rate is 5%. 5%, it means it will be 0.05 and the time is 4 years, right? So you have to find the what's the balance in the second account after 4 years. After 4 years means after this period. What will be the amount in the account, right? So what you have to do, first of all, you will use the first period and find the amount after first period. We know A equals to P and then 1 plus R over N to the power of N T, right? So what's the P principal amount? That is 1200. Then 1 plus R is 0.04. What is N? N is 365 to the power of N times T. N is again 365 and the time for the first period is 2 years, right? So you have to use a calculator and find A from here. I will use my calculator here. So when I use my calculator, I got it as $1,299.94, right? This is the amount after 2 years. This is for the first period. Then because you have to see that this is the compound interest, that is important thing, and this is the second period, right? So you have to use the same formula, this formula here, but what will be the difference? Because we are finding the compound interest, so for the second period this principal will be changed, right? Although the principal for the first period was $1,200, but for the second period we had to take the final amount of the first period. This amount is the principal for second period, right? So we already discussed that compound interest differs from simple interest in the way that we had to take this final amount as a principal for the second period, right? So for the second period, when we will put this into 1299.94 as a principal, and then 1 plus, what's the R? R is already given to you. That is 0.05, right? 0.05 our again, what's the it's again daily compounding, so you have to take n as 365 and then here 365 times for how many years? The period was, it was 4 years, so you have to put 4 here. Then you have to divide these two, then you have to add the answer with 1, then you have to multiply these two and take the exponent, then multiply this with all of these, right? So these are simple calculation. I will simply calculate it by my calculator. So I got 1587.73, right? So this is the amount in the account after 4 years. Here you can see it is then withdrawn and placed in another bank at the rate of 5% compounded daily. So you can see both the compoundings are daily compounding, right? So after 4 years, the amount in the account will be $1,587.73. Then we will see this question number 7. But it says 1200 is placed in an account at 400 compounded continuously. So in the beginning, I told you that there is another type of compounding, like we studied annual compounding, quarterly compounding, monthly compounding. We also discussed weekly compounding, but here it's continuous compounding, right? You have to understand this also. So 1200 is placed in an account. So what's the principal here? The principal is 1200, right? And what's the R? The rate is 4%. 4% means 0.04. Again, for 2 years, time is again 2 years, right? Then withdrawn and placed in. So this was for the first period, and for the second period again compounded continuously 4 years and 5%. So R is 5%, it means it is 0.05, and the time here is 4 years, right? So this time the only difference is that the compounding is continuous compounding, right? So there is a formula to find the continuous compounding. You have to remember that, how to calculate the continuous compounding. A equals to P times e to the power of R T, right? So here we know what's A. A is the final amount, right? P is the principal. You should know E. E is our constant, right? Like pi. We know pi is like 3.14, right? So E is a constant. You can use your calculator to find its value. Its value is I think 2.7 something like that. So E is a constant here, right? You can find its value from any source. So what is A here? A is the final amount. So we have two periods. We will plug in their values here, right? A equals to what is P? P is the principal, that is 1200. Then E, what's the R? R is 0.04. And what is T? T is 2 years, right? So you can use a calculator here, and you will find an option to put E on your calculator. Otherwise, you can find its value from anywhere. It's along here 2.7 and something like that, and you can find it. So when I use my calculator, I got it as $1,299.94, right? So this is the amount for the first period. To find the amount for the second period, you have to use the same identity. A equals to P times ERT. But this time the principal, what will be the principal? Because this is the compound interest, so you will use this amount as the principal for the second period, right? So it will be 1299.94. Then E to the power of R. What is R for the second period? The rate is 0.05. And how many years? The period is it's 4 years. So you will put 4 here, right? And when you use a calculator to find this value, you will get $1,587.75. So how will you calculate it? Like first of all, you will multiply this and this, right? Then you have to take e to the power of that answer, right? For example, if you get it as 0.2, you have to take e to the power of 0.2. Then you have to multiply this whole number with this answer. So you will get $1,587.75. So that will be the balance in the second account after 4 years, right? Then we will see this question. What principal you have to deposit in 4.5% saving account compounded monthly? This is monthly compounding. You have to find the principal. So you can see we need to rearrange the formula in different conditions, like here. For example, when we have to find the principal amount, the rate is given to us, that is 4.5%, right? It means it is 0.045. Compound it monthly, so n will be 12 here, right? To have a total, the final amount should be $10,000. $10,000, and the time is 8 years. So what was the formula we have? It was A equals to P times 1 plus R over n to the power of nt. So plug in the values which are known to you, like the final amount is 10,000. You will put 10,000 here, equals to, you don't know P, so you will put P as it is because we have to find P. P is the unknown value here. 1 plus, what is R? R is 0.045 over n. What's n? Because it's monthly compounding, it will be repeated 12 times in a year, so you have to take n as 12. And what will be the time period T? That is 8 given to you, right? So first of all, you will simplify these two things. Let's use the calculator. And then you have to add 1 to this value, and 12 times 8 is 96, right? So after simplifying all these things, you will divide 10,000 by this whole answer. So because these are simple steps, so I'm just keeping this will be the value of P. And what is P here? If you use a calculator to find all of them, you will get $6,981.46, right? So that's the way you have to find P. Here you can see this question. What's the interest rate compounded annually? Here you have to find R, as we did in the second question above, right? Needed for a principal. What's the principal here? It's $4,000, right? And what's the final amount? The final amount is $4,500. And what's the time period? That is 10 years. So you have to use the formula A equals to P times 1 plus R over n to the power of n t. Again, what's the compound here? Compounded annually, so n will be just 1, right? So you will take 4,500 equals to, the principal is 4,000, 1 plus R is unknown to you, and the time is 10, right? So first of all, you will divide 4,500 by 4,000, right? You will get rid of this. So I need to use my calculator. So then you have to take, here you can see, after dividing these two, what you have to do, you have to take the logarithm for this, right? Like take the natural log. So this is the second way to calculate the r from here, the rate from here. It will be 10 times natural logarithm of 1 plus r, right? So first of all, you will take the natural logarithm of this thing. So let's see. Let me use my calculator. First of all, you have to divide 4,500 by 4,000. So it will be 1.125. Let's see. 1.125, right? Then you have to take the natural logarithm of this value. You will get an option on your calculator to find the natural logarithm of this value. So it will be 1.125. It will be something like 0.0.1178, right? Then you have to divide it by 10. You will get rid of this 10. So divide the answer by 10. You will get 0.01178 equals to ln 1 plus r. Then what you have to do to get rid of this natural logarithm, right? To get rid of this natural logarithm, you have to take anti-logarithm. You will get an option on your calculator to find the anti-logarithm, right? Anti-logarithm of 0.01178. So it will be something like 1.0118 equals to 1 plus r. Then you have to subtract this one on the other side. You will get something like 0.011 equals to r, right? So you can listen to these steps carefully, right? Use calculator to find all of this. You will understand these steps. So it's enough for today, right? We will discuss the next topic in the next lecture. See you. Bye.